Hello colleagues, my name is Peter P. Seerstens of the IOC. First of all, let me apologize for not being with you live today, but I hope that this presentation prepared by Greg Reed and myself will help you along a little bit. So I am going to talk about the IODE Ocean Data Portal. First of all, why do we need an Ocean Data Portal? Well, the problem is that today, through the internet, which has been developed in the past 15 to 20 years, we now have hundreds, if not thousands, of ocean data servers around the world, many of which are providing the data in through different interfaces, in different formats, making it almost impossible for the user to have a single point of access to obtain these data. And that is exactly what we want to provide, a single point of access where users can obtain the data in the same format and do already some analysis and download the data very easily, but also share their own data with a global network. This is done through the IODE, and the IODE is the International Oceanographic Data and Information Exchange Program of the IOC, which is the Intergovernmental Oceanographic Commission of UNESCO. Established in 1961, the IODE program, through its member states, has established a network of 80 national oceanographic data centers in almost as many countries. These data centers are responsible for receiving data, for quality control, for archiving and dissemination of these data. What has always been very important within the IODE program is its data policy, which is based upon free and open access to data. IODE deals with all types of data, physical, chemical, as well as biological data. Traditionally, IODE deals with delayed mode data, whereas programs such as GOOS, the Global Ocean Observing System, deals with real-time data, but the differentiation, the border between these delayed and real-time has been narrowing quite a bit. So back to the Ocean Data Portal, the objective is to facilitate and to promote the exchange and dissemination of marine data and services. It's achieved through building a network of NODCs that provide seamless access to collections and inventories of marine data from the data center. We provide a full range of processes, including data discovery, access, and visualization. And we try through ODP to provide for the data access requirements of all IOC program areas. Let's have a very quick look at the design of the Ocean Data Portal. We can see there is the data provider and there is the integration server. The concept of Ocean Data Portal is that the data remain with the original organization that manages the data, with the data centers. What we harvest, in a way, what we collect in Ocean Data Portal is the metadata. So the first thing here is the integration server, which provides the registration services of the system. Metadata are uploaded to the integration server or are entered manually in the integration server, and it is in the integration server that the querying will be done. And then, of course, as I said, we have the data provider. This is where the data actually are residing. Now, we have services also, and I will come to those a little bit more in detail now. We have discovery, we have viewing, we have analysis, and we have downloads. The discovery service means we can disseminate a data catalog with metadata descriptions based on the ISO standard 19115. And here you see an example. So through this interface you can submit your query and you will get the data sets that respond to your query, and that has been retrieved from the metadata. The viewing service, you can also see here now the data themselves, data points. You can also do some graphing and you can get some geographic information on your data points. The analysis service, we also have a built-in GIS service to provide some interactivity and for displaying multidisciplinary data and products. And here you see an example of that. And of course, finally, you can download your data. You can do that in NetCDF, in ASCII, or in XML. Now, building this system, of course, interoperability is very important, because ODP is not the only distributed data system that is being developed. There are also other regional, such as CDataNet, or national, such as the Australian IMOS. There is also a system developing in the US. So we are not going to compete with these other systems. No, we have to be interoperable with them. In that regard, we're working closely with WMO through the joint WMO IOC Technical Commission for Oceanography and Marine Meteorology, JCOM, to ensure that the Ocean Data Portal, for example, is interoperable with the new WMO information system. Through this cooperation, ODP will provide not only oceanographic data, but will also be able to provide the meteorological data, and the WIS in return will also be able to give access to oceanographic data. Standards, of course, if we're talking about interoperability, standards are extremely important. They are required for all the aspects, for the data discovery, for the data visualization, and for the data access. For that, together with JCOM, we have developed a standards process where we can reach agreement and commitment to adopt certain standards based upon best practices. We are not going to invent standards if it's not necessary. We will use existing practices that can be converted into a standard. And that can be about metadata, about vocabularies, about quality control and whatnot. And a special project has in fact been established. You can see here the whole process going from the proposal submission to the final step of recommending the standard. I already mentioned it, close collaboration with the WMO information system. The Ocean Data Portal will make the data available to the WIS, and it is cooperating through JCOM to ensure this interoperability. In fact, if you look at the structure of the WMO information system, Ocean Data Portal has been designated to be a DCPC. And also, therefore, all ocean data resources will be discoverable through this WMO information system. And you can see here what the elements are. A small brief word about GEOS, the Global Earth Observation System of Systems, which we all know about. Ocean observation and prediction is a major component of GEOS. The WMO information system will be the core component of GEOS for weather, water, climate and disaster societal benefit areas. And so, because ODP is linked to the WIS, ODP will also contribute to GEOS. Thank you very much for your attention.